Hello students, it's just me, Mr. Wee. So we're actually going to get started on 6-1, 6-2, and 6-3, but we're going to start at section 6-1, which has to do with a bunch of triangles. What I just opened for you right now was a cheat sheet that I actually created for you guys a while back. Let me see what's kind of going on here. Some things are kind of loading. So if you go to your website, or if you go to my website and you go all the way down to the month 5 cover sheet, you'll see that I have two links to the 6-1, 6-2, and 6-3 cheat sheet, as well as the 6-4, 6-5, and 6-6 cheat sheet. Some things that are unique to this year as well. Before we start our section, let's take a look at the cover sheet really quick. So again, this is only applicable for the 2018-2019 year. Any other year, or if you're watching this and this is you're in the class of 2019, 2020, or so forth, this information may not be applicable. You can kind of skip ahead to the content. Okay. All right. Well, anyways, for my 2018, 2019 kids, the cover sheet is as follows right now. The first 6 lines are going to be new material. Sorry, it's taking a little bit of time. And then I have 2 lines where it's just review for your final, which goes back to content that's from the earlier sections, from like section 1-5, as you can see right here, 1-7, and so forth. And then right now, as I'm showing you this, I have some SAT level questions and some things that you're going to have to do that I will explain in further detail, I think, after the winter break. But I'm gonna put this up over the winter break, though. However, so I didn't have time to put it up right now because they're actually going to be more involved questions, and I'm going to actually have you write out your answer in words, and I'm going to see I'm going to kind of grade it and maybe give you a rubric of how I'm going to grade that, like a very general rubric. But right now the links are not here. Okay. All right, guys. So let's go ahead and begin. Section 6-1, right? Let's see. Okay, so sorry for getting the wire out there. And we're gonna bounce back and forth between the web page and this document camera. All right. So the first thing that we're gonna write is 6-1, area of triangles. Okay, and then we're going to look at the triangle angle sum theorem. So we're going to look at the triangle angle sum theorem. And basically what this is all triangles, no matter how you draw them. Let's see, all triangles will have their interior angles sum up to 180 degrees. So you can draw any triangle you want. Okay, like that was my attempt at doing an equilateral triangle. You can do a right triangle. You can do which is 45 degrees on both of those sides, or you can have a, let's see if I can draw this a little bit steeper. You can have a 30, 60, 90 triangle. Doesn't matter what triangle that you draw, but if you actually have a protractor and you actually drew your line straight here, or you did it in a way where all the lines are perfectly straight and each of the points are actually connecting and intersecting at these vertices, at perfect vertices, then you should measure that the angles add up to 180 degrees, any triangle. Okay, so that's actually on your cheat sheet as well. I have that, but I think most people have that. So you can kind of see that in this example here, in this triangle, angles A, B, and C are going to add up to 180 degrees. I'm going to go over just very briefly like an example that you might see in the book, and then we're going to move on to the next subject because this is pretty simple. Okay, sorry for the lighting here in the shadow, so you're gonna have to kind of work with me here. So I'll fix that in the next video, but can't really change my position right now. Using the triangle angle sum theorem. So here's an example of this. So why don't you draw like a sort of like an X bar in this way, and then we're going to connect the vertices. And you gotta ask yourself, how many triangles do you see? I see 2, and let's name these vertices A, B, C, D, and E. Okay, so this is gonna be 20 degrees. This is 3. This is called angle 3. This angle is 78 degrees. This is angle 2. This is 61 degrees. And then this is angle 1. Okay, so notice though, I was very specific in saying that this angle A in the corner here measures to 20 degrees. This is called angle 3. There is no measure for angle 3, so we might have to solve for that. This is 78 degrees. This angle ACB, so A to C to B is 78 degrees. Okay, this angle is just called angle 2, but this does not have a degree symbol, so this angle is not 2 degrees. Okay, angle E right here in the corner is 61 degrees, and this angle is literally just labeled angle 1. Okay, so the problem that I'm going to present to you is just to find the measure. Find the measure of each numbered angle. All right, so let's use the triangle angle sum theorem, which, well, let's do it. I think this one's a little bit tougher because right now I'm asking you to find the measure of each numbered angle, meaning 1, 2, or 3. 1 and 2 are both mysterious angles that I don't want to solve for right now. It's really hard to do what I'm about to do with this scenario where I have 2 angles that aren't even equal to each other necessarily. We don't even know if they are. They're both mysterious. And yet I only have 1 known angle. This one's a lot easier. Triangle ABC, because I know in triangle ABC, if I add the measure of angle A plus the measure of angle B plus the measure of angle C, they should add up to 180 degrees, according to the triangle angle sum theorem. Okay. All right. So why don't we substitute in the values I have? I have angle A being 20 degrees. So let's substitute in that value. The measure of angle B is just called angle 3. So we'll just call it the measure of angle 3. It's equivalent to the measure of angle 3. It's the same thing. And then the measure of angle C is 78 degrees. So we do have a value for that. And we know that adds up to 180 degrees. Sorry, I forgot to put in the degree sign previously. And then let's combine like terms. So measure of angle 3 is not a like term from 20 degrees and 78 degrees, but 20 degrees can add up to 78 degrees. That'd be 98 degrees. That used to be an old boy band from, I think, the late 90s, 98 degrees. Just a little bit of fun trivia there. And then what you're going to do is you're going to subtract 98 degrees from both sides. And I believe that leaves you with the fact that the measure of angle 3 henceforth is 82 degrees. Okay, not bad. So we got 1 angle so far, but how do we solve? So that was really easy because I had 2 of those angles known, and then I just solved for 1 unknown angle. Here I have 2 unknown angles, so that's going to give me some problems. And I'm going to kind of like draw like a little squiggly line. You don't have to do it in this way, but I'm going to do the same thing that I did for this triangle. I'm going to apply the same concept to this triangle, which is the measure of angle I call E plus the measure of angle. So this is where I think it's really important to actually be very specific with what you're talking about. Are you talking about angle C in this triangle? Or are you talking about angle C in this triangle? In this triangle, in the bottom or the top? So to make it very clear, how I'm going to do it is I'm not just going to call it C, because C is a little ambiguous for knowing which angle you're talking about. I'm going to say that angle C, I'm going to name it ECD. Okay, when I say E, so how you connect angles is you start from the outer vertice to the inner angle to the outer, or to the outer exterior vertex or leg. Okay, so that's usually the naming convention. So this would be angle AECD, or the same thing could be DCE. But notice that I always leave the middle letter, the middle letter where the angle actually conjoins and is created by these 3 points. Does that make sense? Okay, so it doesn't matter if I call it D to C to E or E to C to E. Okay, it just has to have C in the middle to indicate that that's the angle that's being made with these 3 points, and it conjoins at that middle point at C. Okay, and then I'm going to say that the measure of angle D, all of those should equal 180 degrees. Now let's substitute in some values. I know that the measure of angle E, I shouldn't have done that. The measure of angle E is explicitly written as 61 degrees, so I can write in 61 degrees. Where things get tricky is the measure of angle ECD and the measure of angle D. So I'm going to say that the measure of angle ECD is, all we know is we can substitute in for, that's the measure of angle 2, but that's not, remember, the number 2 is not the actual measure of the angle in degrees. It's just the naming, it's just another name for that angle. And the same case is with the measure of angle D. So that's just, the measure of angle D is literally the measure of angle 1. It's the same thing, which is 180 degrees. So how the heck are we going to solve for this? I have 2 unknown numbers, but if you think back to it, if you create any triangle and you look at angles that are vertical to each other, such as A to C to B compared to E to C to D, these angles across from each other should be exactly the same. Okay, any intersecting angles like this, I just drew that on the spot, didn't even do anything, it didn't even mean for anything. If you actually used a protractor to look at these 2 angles, like this angle, this left angle across from this right angle, or vertical to this right angle, they're going to measure exactly the same. Same as this angle across from this angle, it has to be straight across or vertical to this angle. See, it looks roughly about the same anyways in this crude drawing. How about this? Let's try that one more time. I do crisscross, but it's like where it's much more narrow and tight the way that they intersect. But look, you can clearly see that this angle vertical from the angle of top or across from it is about the same. Same with these smaller, tighter angles. They are vertical to each other. They are equal to each other. So due to the vertical angle theorem, we call those vertical angles. This measure of angle A to C to B, which is 78 degrees, should be equal to measure of angle 2. So let's just say that, let's make a note up here that the measure of angle 2 is actually equal to the measure of angle ACB. And if we just have to write that up there. It really helps. You don't have to write this, but it really helps to say why, because this is the vertical angles theorem. Vertical angles theorem. Okay, and knowing that ACB is equal to 78 degrees, and then measure of angle ACB is equal to that measure of angle 2, we're going to put in place of that, let's rewrite this one more time, we're going to say that that's equal to 78 degrees. Okay, the measure of angle 1, however, is still not known. That's truly the only angle that we have to solve for. So if that's the case, we can say that the measure of angle 2 was equal to 78 degrees. So that's one fact as well. Sorry, so I forgot to kind of highlight that. But now we're just solving for the measure of angle 1. Let's add 61 plus 78. That's about 139 degrees if you add those together. And then we're still solving for the measure of angle 1. And then simply just do some algebra to solve what the measure of angle 1 has to be in order to add these 2 angles together to make 180 degrees. You subtract 139 degrees from both sides, and that should leave you with just the measure of angle 1. It's not bad, huh? The measure of angle 1 should be equal to about 41 degrees. Okay, there we go. All right, so let's continue on. We're not finished yet. I was going to say you can try, actually, let's do a little bit more of a difficult one then. Here, I'll give you one you could try at home, and then I'll just give you the answers for it. And then I'm going to give you a complex one that you could try at home, and then I'll go over it briefly. Okay, so let's see. And I believe this is in your book too. So let's draw this one here is an example number 2. It'd be this triangle here. So you can kind of emulate how I'm going to draw this triangle. There's a vertex here. This vertex connects to this vertex. And then we're going to split this off into like 2 triangles here. And we're going to call this point K. They're going to call this point J, L, and M. And then we're going to say this is angle 3, this is angle 1, this angle is 28 degrees, this is 71 degrees, this is angle 2, and then 57 degrees. Okay. And then we're going to solve for each measured angle here. I'm just going to go ahead and pause that and try that. I'm going to leave you with just the answers to see if you did it correctly. And then I'm going to move on to the next question. All right, so hopefully you try that out. That's the answers that you should have gotten. I'm going to move on to a more complex one for you to try, example 3. Okay, so let's draw a straight line here. Let's draw a point here. Let's connect this point to this point. We're going to call that Y. We're going to call this point Z. Okay, and then we're going to put another point here called V. This is a more advanced problem, but one that you should be able to do. So in here, this is 58 degrees. In here, this is 65 degrees. This is called angle 7 in this corner. In this corner right here, this is called angle 6 in this corner. I believe this is called angle 9 in this corner. So these are the numbered angles that you're going to have to solve for. Over here is angle 8. Uh-oh, that's going to be pretty tricky. So that's angle 8. It's angle 4, 5, and 67 degrees. So, and I forgot to name this point here. This point is W, and this point here in the middle where everything intersects is X. Okay. All right, you could try this on your own if you want to just kind of, I don't know, try it on your own. Okay. But if you're done and you want to, or if you want me to chat, or if you want to check with me, or you don't know where to start, let me begin by helping you. Okay. So it looks like, okay, so I see about a few different triangles actually. I see like this, there's many ways you could have done this. Okay. But I'm going to show you one way that you could have done it. All right. And by the way, this is not a right angle. This is angle 7. Okay. So sorry, let me draw that as a different kind of 7. Okay, so that's not a right angle, that is angle 7. So this one has 3 unknown angles. Measure of angle, this is a 6, 8, and 9. Those are not angle measures because they don't have the degree sign next to them. It's just calling this angle 6, 9, and 8. They're all unknown, so that's not going to help. That's not going to help me at all. I'm going to try to use the triangle that has the most given information. So this has 2 angles that are already given, like angle measures that are already given here, and yet this one here is the only one that's not given. Here has 2 unknowns, which makes that difficult, and 1 known value. So I'm going to stick to this triangle here. So let's stick to this triangle, okay? I'm going to say, so this is the measure of angle Y. So this is for this triangle here. The measure of angle Y plus a measure of angle 7, what they call it, plus I'm going to say this is Y, Z to X, because this is getting really confusing. If I said this is angle Z, what are you talking about? Are you talking about this angle Z? Or are you talking about this angle Z? So you have to be specific. Y, Z, X is equal to 180 degrees. Okay, every triangle that you create, if you add the internal angles together, it should be 180 degrees. Okay. Let's try this out. So the measure of angle Y is 58 degrees. Let's substitute in the values that we see. The measure of angle 7 is the one that we're trying to solve for. And the measure of angle YZX is 65 degrees. This is not too bad. So 180 degrees. I'm going to do some quick math. See how quick I am. See, I think this is 123 degrees. This is 180 degrees. Then we're going to subtract 123 from both sides. That should leave me with, I think, 57 degrees, if I'm not mistaken. Yes. Measure of angle 7 is 57 degrees. Okay, so we're off to a good start. We got one angle so far. Okay. Now, there's a lot of other things that you could try. Let's see. You could try using this as a big triangle. What I like doing, it's a little bit trickier, but you got to recall on information from the past. But I say there's a relationship between measure of angle 7 and measure of angle 6. Think about what that relationship could be at those two angles. Well, they're on if these are triangles, okay, if these are drawn to be triangles, then these should be straight lines. And what we know about a straight line, any straight line, okay, so you don't have to draw this, but any straight line, if I draw a line through it, this straight line to this straight line, A to B, if you cut another line across it, if you add up the angles here, I added two just dash marks saying that this angle measure is different from this angle measure. As long as it kind of originated from a straight line, it should always add up to 180 degrees. So this and this should add up to 180 degrees. Well, 7 and 6 are on a straight line, so I should recognize that the measure of angle 7 and the measure of angle 6 is also equal to 170 degrees. So I'm going to say that the measure of angle 7 plus the measure of angle 6 is equal to 180 degrees, because that's 180 degrees right there. From one line to the other point here, if we're starting from like this point here and saying that the angle starts from here all the way to the end of this line over here, that's 180 degrees, okay? So I know that based on what I have here for the measure of angle 7, I'm going to say that's 57 degrees, and I don't know what the measure of angle 6 is, but I can solve for it simply by just subtracting 57 degrees from both sides. I believe that should give me the measure of angle 6 is equal to 123 degrees. Not bad. Okay, but this does not help me too much for this triangle here, because 8 and 9 are still not solvable. And can I apply that same thing, that this angle here, yzx plus angle 9 is equal to 180 degrees? Well, ask yourself, does it come from a straight line? Not quite. This is a bent angle. See that? The angle, or like the line, that they don't even share a line if you think about it. They're not on the same line, right? YZX, this angle is sort of on this line here, and then angle 9 is sort of on this line here. Whereas angle 6 and 7 were all on the exact same line. You could do that. You could say that a measure of angle 7 plus 6 is equal to 180 degrees because they're on the same straight line. But you can't apply the same thing here to here. So I'm sorry, but can you see any other angles that we need to solve for that do, or that are on this similar straight line? I see 6 and 5. 6 and 5 are on, those angles conjoin to make, or are on a similar line, a straight line. Do you see the straight line? Okay, so I'm going to say that the measure of angle 5 plus the measure of angle 6 is equal to 180 degrees, because they are angles that are conjoined on a line, a straight line. Okay, so, and we just solved for the measure of angle 6, so that's 123 degrees. The measure of angle 5 is right here, which is equal to 180 degrees. Let's subtract 123 degrees from both sides. Then we should have the measure of angle 5 is now equal to 57 degrees. That's very funny, because since the measure of angle 7 and the measure of angle 6 were on the straight line, the measure of angle 7 was 57 degrees, and then the measure of angle 6 is 123 degrees. But because the measure of angle 6 also is on a straight line to the angle 5, and it's still 123 degrees, then that should make the measure of angle 5, oddly enough, equal to this. That's just not a coincidence, but because they share straight lines with measure of angle 6, they are going to end up the same. But there's no way you could have, actually, I think if you guys were really inquisitive, you guys could have seen that the measure of angle 5 is actually completely vertical to the measure of angle 7. So you could have said, because they're vertical angles, they're equal to each other as well. There's so many ways you could have solved for this problem, okay? But we're not done. We still got the measure of angle 4. And we still got the measure of angle 9. Let's see. And I believe we still have the measure of angle 8 Yeesh. I am not a huge fan of what's going on here, but we're going to try our best to figure this out. Okay. Okay, so let's see. Then we got the measure of angle 4. So let's look at this triangle here. We got that the measure of angle, so let me zoom out a little bit here. Let's look at this triangle here, up here in the left, on the left. I say the measure of angle 4, I'm sorry, plus the measure of angle, I'm going to call that VW to X, measure of angle VWX, plus the measure of angle 5 right there is equal to 180 degrees. And we do have values for the measure of angle 5 at least. The measure of angle 5 that we just saw for was 57 degrees. The measure of angle VWX, V to W to X, or you could have said XWV, is 60, what does it say? That is 67 degrees. And then now all I have to solve for is the measure of angle 4. Okay, so let's go ahead and do some math here. I believe that is 124 degrees. Is that right? 124. Yep, that's 124 degrees. Add these two. The measure of angle 4 has not been solved yet. So we're going to subtract 124 from both sides. And then you should get the measure of angle 4 is now equal to 56 degrees. Very close, but it's not. It's very close to our other two previous angles, which was the measure of angle 7, the measure of angle 5, but not quite. It's a little bit different. Okay, so now we're down to this last one in here. Oh, I'm sorry. We're down to 2 last ones that are, I think, very, very tricky. Okay, so what are we going to do here? I'm having a little bit of a difficult time. Let me think about this too. Actually, yeah, I really got to think about this. This is not an easy problem. Okay. Oh, I believe I'm missing something here. Let me double check. I think I'm sorry. I forgot to add one fact that is crucial, because you actually can't solve this without this crucial fact. And I'm not just making this up. This is literally from your book in Guided Practice, your first 2 guided practice problems. Phew, I was getting really scared. It did state that the measure of angle 8, I'm drawing little arcs around 8 and 9. If it has one arc, that means it's written as one arc. That means measure of angle 8 is equal to the measure of angle 9. Oops, sorry. I was writing it down here. And let's go back in here. We know that the measure of angle 6, 8, and 9, if you add them together, are going to equal 180 degrees because they're in the same triangle. Measure 6 plus the measure of angle 8 plus the measure of angle 9 is equal to 180 degrees. And I learned that the measure of angle 6 from previous solving is 123 degrees. And then, you know what? Just to make this easier, because right now the way this is written, it looks like I have to solve for 2 different angles, right? But let's just substitute maybe the fact that the measure of angle 9 is also equal to the measure of angle 8. Let's say that this is the measure of angle 8, and let's just substitute in, instead of having 2 different angles to solve for, let's write that again as the measure of angle 8 is equal to 180. And let's subtract 123 from both sides. And if you think about it, that's the measure of angle 8 plus the measure of angle 8. It's sort of like there's the two measures of angle 8 being added together. That's like 2 times the measure of angle 8. Or 2 of the measure of angle 8 is equal to, what would that be? I believe that is 57 degrees. So we're saying if you added, so what that says is basically if you have the measure of angle 8 added together twice, like whatever the measure of angle 8 is, and then you multiply that value by 2, you should get 57. So what does that tell you about the singular value of just one measure of angle 8. Well, the only way you're going to solve for that is you just divide both sides by 2, the way that you have written this out. The way that you mathematically written this out, you can solve it conceptually just by saying, or just by dividing both sides by 2, because you just wrote it out like, hey, if I have 2 measures of angle 8, whatever the measure of angle 8 is, and I doubled that value, I should get 57, but I want to find what just the measure of angle 8 by itself, not twice that value is equal. I want to see what it equals to, so you just divide both sides by 2, you get the measure of angle 8. That should be 28.5 degrees. So that's good. And you know that the measure of angle 8 is equal to the measure of angle 9, because that's what I should have showed you in the picture here, so I do apologize. 8 and 9 are equal to each other. Then you say the measure of angle 9, since it is equal to the measure of angle 8, that's going to also be 28.5 degrees. Okay, that was a pretty tough one. Okay. We're going to go ahead and stop, and I'm going to continue on. So this is just the first part of 6-1. Okay, thank you guys so much, and let's take a break. Bye.